Section 10.1, limits, question number 40 on page 468. So, number 40. So, again, we are evaluating the functions. We're finding the limit as h approaches 0 of f of x plus h minus f of x over h. And for number 40, f of x, the expression that we're going to plug in here is x squared plus x plus 1. Okay? So the first thing we need to do is rewrite the limit expression notation. And so we want to have this quadratic equation evaluated at x plus h. So it's going to be x plus h squared, the first term. So remember, we're plugging in x plus h for x in this entire expression first. So x plus h squared plus x equals x plus h. So x plus h, right, that corresponds to the x value, plus 1. Okay, so now we have the first part of this expression, f of x plus h, taking the quadratic form. Now we want to just plug in minus f of x, which is x squared plus 1 plus x plus 1. So it's going to be minus, so all these terms are going to be negative. So it's going to be minus x squared minus x minus 1. And of course, all of this is going to be over h. And you can imagine a bunch of stuff's going to drop out, but we need to do some more math first. So the limit as h approaches 0. So we deal with this term first. Remember, you square the first term, then you multiply the two terms and double them, plus 2xh, and then you square the last term, plus h squared. So that takes care of this term here. We've got plus x plus h from this term here, plus 1 from here. And then we've got, of course, negative x squared minus x minus 1. And all of that is going to be over h. Okay, so we've got an x squared here. We've got a minus x squared there. Those drop out. We've got an x here and a minus x there. Those drop out. We've got a 1 there and a negative 1 there. Those drop out. So we're left with 2xh plus h squared plus h in the numerator over h. So h will then cancel out of these three terms. This is going to be left. This is going to be a 1 here. And so we're going to have the limit as h approaches 0 of 2x plus h plus 1. H approaches 0. That means this term is going to be 0. This term here is going to be 0. And so we're left with 2x plus 1 as the limit of this expression, f of x equals x squared plus x plus 1, evaluated within this larger expression here. The limit of as h approaches 0 of f of x plus h minus f of x over h. It seems like a strange expression, but it's actually going to come into play pretty intensely and importantly in the next few chapters. So that's why we're using it, and that's why you are going to be very happy you did all this work now in a bit. Anyway, you got your answer. We're done with the video.